Welcome to Fiber Optics Communication Systems by EFACT. Module 1. Introduction to Optical Fiber Communication Technology. Basic structure of an optical fiber cable. The innermost layer is called core layer. The refractive index of a core layer is denoted as N1. The outer layer is called cladding layer. The refractive index of a cladding layer is denoted as N2. Generally, refractive index of a core layer is greater than that of a cladding layer. That is, N1 is greater than N2. To provide strength to fiber optic cable, buffer coating or a Kevlar layer is provided. Basic block diagram of optical communication system. Electrical signal is converted into optical signal in the transmitting section with the help of driver circuit and light source. Repeater stage is necessary if the fiber optic cable is used to transfer the data for longer distances. At the receiver end, it is again required to convert optical signal into an electrical signal, and this is done by using an optical detector. Advantages of optical fiber communication: large bandwidth, high transmission capacity. Fiber optic cables are light in weight. Also, the size of fiber optic cable is small. No crosstalk generation. No short circuit hazard problems. Disadvantages of optical fiber communication: connecting and splicing of optical cable is difficult. Non-linear response of light sources. Difficult to distinguish between positive and negative signals. Efficiency of light source is poor, so the efficiency of total system is reduced. Fault management is a complex process. Ray theory of transmission. Refraction. When the light ray travels from one medium to another medium like glass, then bending of light ray takes place. Refractive index is defined as the ratio of speed of light in air to the speed of light in another medium like glass. Therefore, refractive index is defined as N is equals to C by V, where C is speed of light in air and V is speed of light in another medium. Law of reflection. The angle of incidence is equals to angle of reflection. The angle made by incident ray with respect to normal is called as angle of incidence, phi 1. Similarly, the angle made with vertical line at which the light is reflected from the surface is called angle of reflection, phi 2. Therefore, phi 1 is equals to phi 2 is known as law of reflection. Snell's law. When the light ray meets the interface of two media having different refractive index, then the part of light ray is reflected back into the first medium and other part is refracted into the second medium. Snell's law is given by N1 sin of phi 1 is equals to N2 sin of phi 2. Critical angle. It is observed that the value of phi 1 goes on increasing, the value of phi 2 also gets increased. At one particular stage, the value of phi 1 is such that it makes angle phi 2 equal to 90 degree. This is called as the critical angle of incidence, phi c. Therefore, critical angle phi c is given by sine inverse of N2 by N1. Total internal reflection. If angle of incidence is increased than critical angle, then the light ray gets reflected rather than causing refraction. This phenomenon is known as total internal reflection. The total internal reflection occurs at the interface between two dielectrics having different refractive indices. The TIR, that is total internal reflection, occurs only in materials in which the speed of light is slower than in air. Numerical aperture. Numerical aperture is a light gathering capacity of an optical fiber. Numerical aperture is defined as n sin of theta naught max, where n is refractive index of air, which is equal to 1, and theta naught max is the maximum angle at which light enters the fiber and causes internal reflection. It is known as acceptance angles of an optical fiber. Numerical aperture is also given by square root of n1 square minus n2 square, where n1 is refractive index of a core layer and n2 is a refractive index of a cladding layer. Numerical aperture can be also calculated as n1 square root of 2 delta, where delta is the relative refractive index difference between core and cladding layer, and it is given by delta is equals to n1 minus n2 upon n1. So in this module, we have studied basic structure of an optical fiber, basic block diagram of optical communication system, advantages and disadvantages of optical fiber communication, ray transmission theory, concept of critical angle, total internal reflection, and numerical aperture.